let's integrate e to the x cosine x dx. So this question was actually recommended by a comment, and I thought it was pretty interesting, and I'd like to share it. So this is another integration by parts question, but it's not a typical one. So let's start. Let's just get into it. So for this integral, I'm going to set my u as cosine x. You could refer back to the acronym that we use to prioritize what u would be equal to. But anyways, so my u is cosine x, and du would be equal to minus sine x dx, right? Because that's just a derivative of my u. And then v and dv. Actually, let me write down what our integration by parts question is, or equation is. So you'd use integration by parts when your original integral is in the form of u dv, so that then you could solve it for v u minus the integral of v du. And that's what I'm trying to do here. So I'm assigning my dv as e to the x dx, and my v is going to be equal to e to the x, because the integral of e to the x dx is just e to the x. So let's plug everything into our integration by parts equation. So v is e to the x times my u, which is cosine x, minus v is e to the x, and my du is minus sine x dx, but I'm going to take that negative out, and so it turns this minus sign into a plus, and it's multiplied by sine x dx. So now you already might be sensing some trouble from this integral, but let's just keep going. So you would need to apply integration by parts again, and so pretty similar to our first one, so u would be equal to sine x, because it's a trig function, and our du would be equal to cosine x dx, and then my dv would be equal to e to the x again, and so my v is going to be e to the x. So let me just write this as 1 so that we can keep track of our functions, and then 2 would be equal to, my u is sine x and my v is e to the x, so e to the x sine x minus the integral of v, which is e to the x, times my dx, which is cosine x dx. So now I'm back to square one, and what I have is my original integral of e to the x cosine x dx is all equal to what we did in the beginning. So it's this e to the x cosine x combining with that second integration by parts. So e to the x sine x minus that integral of e to the x cosine x dx. So we have two integrals of e to the x cosine x dx. So we could just combine these two. So I'll take this integral to the other side so that it adds with this integral, so that I have two factors of the integral of e to the x cosine x dx, all equal to what's on the right hand side. Oops, what did I just do? It's all equal to what's on my right hand side of the equation. I'm too lazy to rewrite all of that. But anyways, now all I have to do is just divide by that 2 factor, so that my integral of e to the x cosine x dx is equal to, you could factor out that e to the x, so e to the x cosine x plus sine x all over 2, then obviously plus your arbitrary constant c, and that's it. It's a pretty sneaky question, pretty interesting, and pretty cool.